Sometimes people need help. And that's okay, because I gave it to you. So this is your 1.3 homework for your MyHRW assignment. Keep in mind that since 1.3 is so short, you do only have a couple of days in class to work on this assignment. But let's go ahead and hop right into it. I've already got it pulled up on my screen. So this is an example of what problem 1 might look like for you. So what I see first of all is it's asking us to enter g of x in terms of f of x after performing the given transformation. So in case of this first one, they want us to translate the graph f of x left 2 units. So first we're going to need to get the graph that illustrates that. So this is pretty well centered, and we are going by 2's. So if I want to move this over 2, I'm actually only going to move it 1 square, because each square is 2 steps. So definitely pay attention to the scale that you have. If I want to move this left 2, I'm going to have 1 square to the left, and this is going to move 1 square to the left, and that's all the movement we're going to have. Let's see if I can find one that does that. This looks like it moves 2 units up. This moves 2 units to the right. This moves 2 units down, so B moves us 2 units to the left. So that's the one that we're going to go with. However, I did what many of you did on the previous homework assignment, which was after I answered it, I failed to come all the way down. So they want us to describe the transformation in terms of f of x. So remember, if we're moving left and right, that's going to be addition or subtraction inside of parentheses. So we are going to have f of x, and since we are moving to the left, that is backwards from what we think. Left would normally be minus. So I'm pointing to my left on the screen, so we're moving left, which would be my right, your left, plus 2. So f of x plus 2. Perfect. Next question. Enter g of x in terms of f of x after performing the translation. So we've got the exact same type of question, except this time we're going to move it up 5. So looking at my scale, once again, I have, it's moving by 2's. So I'm going to move up 2 1/2. And I want it to still be centered. So I'm going to look for a graph that's got this point up 1, 2 1/2. So it's going to be at 9. Here we have a point that's at 9. So C is my graph. And in order to describe this transformation, I've got f of, lowercase f of x. And since we're moving up or down, that's going to be outside of the parentheses. This is moving up, so it's plus 5. All right. Let me fix this here. Got everything in the wrong spot today. Alright. There we go. That is f of x plus 5. We are correct. Next question. Enter g of x in terms of f of x after selecting the correct graph with given transformation of the graph f of x. So once again, same thing, different graph shape. So we want to translate f of x down 4 units. So it looks like once again we are in, our scale is by 2's. So this graph shifts down 2. This graph shifts down 4. So B is our most likely answer. Let's double check the others though. This goes down 5, 2, 4, 5. This goes down 6. So B is definitely our answer. Since we are moving down 4, g of x is going to be f of x And then since it's moving down, we're going to have minus 4. So g of x equals f of x minus 4. Next. Okay, we're correct. So next question, please. Thank you. Okay, this time we are stretching the graph horizontally by a factor of 3. So a horizontal stretch by a factor of 3. Select the graph that illustrates the above transformation. So we should stay in the same place vertically, so we know it can't be A. We're not reflecting, so it can't be D. So we just need to figure out which one of these is a horizontal stretch. And they both are, but this one you can see also is a compression vertically, because we should still be at 2 and this one's not. So it has to be this one. Now keep in mind, when we have f of x and we are doing a horizontal horizontal compression or stretch, the number we're multiplying by goes inside, and it's always going to be 1 over the number they give us. So if it's by a factor of 3, that's what we're looking for. F of 1/3 of x. So let's get that typed in. F of fraction 1/3 x. Close. Next question. Compress the graph horizontally by a factor of 1/3. Okay, so we have just a regular absolute value. So if I'm going to compress this horizontally, I'm going to squeeze the outsides in. So I'm looking for something that does this. Same graph, but narrower. So this is the graph rotated, this is the graph shifted down, this is the graph horizontally stretched, which leaves C to be the only one that is a horizontal compression. Now they said this is by a factor of 1/3. Here's a trick for you guys though. Instead of saying 1/3, remember that we're always going to do 1 over the number they give us. Now you could think of that as 1 divided by 1/3, which is 1 divided by 1/3, which is 1 times 3, or 3. Or, as long as this top number is 1, you can just look at it this way. You can also just look at it as whatever they give you, flip it over the fraction bar. So they gave us 1/3. That tells us that we need 3/1, and 3 divided by 1 is 3. Bunch of different ways you can get there. I'd recommend learning it as just flipping it. So 1/3 becomes 3/1, and 3 divided by 1 is 3. So we have our graph. This is f of, and because it's horizontal, it goes inside the parentheses. So this is going to be 3x. Next question, already to number 6. Enter g of x in terms of f of x, same thing. Okay, so we are compressing the graph vertically by a factor of 1/2. So since it's vertical, we know that we are going to squeeze it down. So this rotates, this is a shift, that's a dilation or a stretch, leaving A to be the one where they have stretched, or they have compressed it down. And since this is a factor of 1/2, remember, since it's vertical, it's going to go on the outside. So we have a fraction, 1/2, and it goes on the outside of our f of x. Nice and simple. On to number 7, if it will load. Thank you. Okay, reflect the graph f of x across the y-axis. So since we're going across the y-axis, that is a horizontal reflection, which tells us that we need to be, our negative sign needs to be inside our f of x. And all we're doing is flipping it. So our graph currently goes up and then down, so we need to look for a graph that goes down and then up. So all of B, C, and D all go up and then down, so that tells us it's wrong. A is the only possibility. And the only thing we've done is reflect it, so we're going to have f of negative x. Keep in mind that that negative sign has to be on the inside. If it's on the outside, you're flipping vertically. Next question. Enter g of x in terms of f of x after performing the given transformation. So once again, it's the same type of thing. This time we're reflecting across the x-axis. So flipping across the x-axis is a vertical. So right now our graph opens up, so we need to find a graph that opens down. So both B and D open down, but we can see that this is kind of narrow, and this one is not. So we know that our answer has to be D, because all we were supposed to do was flip it over the x-axis. Since this is now a vertical transformation, your notes will tell you that the negative sign goes on the outside. So it's negative f of x instead of the previous question, which was f of negative x. Those are two different things. Alright, so now we have to reflect the graph of f of x across the y-axis. So we've got this little arc here, and if we flip it across y, we should have this arc. So we need to find this. It's right here. And they still want us to give in terms of, so since we're flipping across y, that is once again a horizontal reflection. So all we have to do is recognize that a horizontal reflection is f of negative x. Put the parenthesis in the wrong spot. F of negative x. On to question 10. Now they want us to flip it across the x-axis, so we have that same arc, and if we're going to flip it across the x-axis, it's going to look like this. So we need to find this arc. And it looks like A to me. Since we are now doing it vertically, we are going to have our negative sign on the outside of our function notation. So to have negative f of x. Alright, now moving on to number 11. Remember, this is where our SAT style questions start, so they get a little bit more involved. So describe how to transform the graph of f of x equals x squared. So remember, identify parent function. We have x squared as our parent function. To obtain the graph of the related function g of x. By related function, they just mean it's still going to be a quadratic. Then select the graph of g of x. Okay, so g of x equals negative f x plus 4 over 8. All right. So since the negative's on the outside of our parentheses, we have a vertical, which means, it's a vertical reflection, which means it's going to be across the x-axis. Since we have division on the outside of the parentheses, notice that the f is is included in this division, so the division is on the outside of the parentheses. That's going to be a vertical change, and since it is one keep in mind that if you see something like this, f over 8, that's the same thing as saying 1/8 times f. So this number is smaller than 1, and your notes will tell you that that means that's a vertical compression by a factor of 1 over 8, because that's the number, is 1/8. And then we are translating 4 units. We have addition inside the parentheses, so it's opposite of what we think. So it's going to be a translation left. So we need to take x squared. We need to translate it. First we need to flip it. Then we need to compress it. And then we need to shift it. So what we're looking for is this line right here. So it should be super skinny. Oh, but they have a very tall scale, so that's why it's not. So this one, they've shifted up. This one, you don't even see. There's that. They've shifted to the right. This one, they've shifted left, but they haven't reflected it, and they didn't shift it left far enough. This one is shifted left 4, and it's reflected downwards. Alright, next question. Once again, we're starting with x squared, so that's our parent function. That graph. Okay, this time we've got f of 2x plus 1. So the graph of g of x is a horizontal because it's inside, and it's a number bigger than 1, so we would expect it to be a stretch, but it's inside parentheses, so it's opposite. It's a compression. So this is a horizontal compression by a factor of, they gave us 2, so it's going to be 1 over 2. In a translation of 1 unit, this plus 1 is on the outside, so it's vertical, and because it's outside, it's the way we think it should go. Plus means up. So we have 2 that are shifted up. This one is horizontally pulled apart, so that's a stretch. C, though, is horizontally pushed together, so that's the compression we're looking for. Number 13. Once again, we're talking about x squared. Find a function g of x that models the given situation. Point C is the vertex of g of x. Restrict the domain of g of x to values that have meaning in the given situation. Flying buttresses were used in the construction of cathedrals and other large stone buildings before the advent of more modern construction materials to prevent the walls of large, high-ceilinged rooms from collapsing. The design of a flying buttress includes an arch. In the illustration shown, the unit of measurement for both axes is feet, and the vertex of the arch is point C. Find a quadratic function in the form g of x equals a f of x minus h plus k that models the arch, and state the function's domain. Okay, so we have not done all of this yet, but hopefully you guys can see that if this is the vertex, that means we are shifted 2 to the right and 12 up. So that should tell you our h and k already. So let's go ahead and get that put in there first. So the equation that models the arch is, and they want it in the form of, okay, they still want it in our f notation. So we're going to have a times f, a times f of x minus h plus k. Okay, so we said we're moving 2 to the right, so that would be minus 2. So h is 2. And then we're moving 12 up. Now all we have to do is find what our a value is. This is not something that we've done yet, because this is actually part of 1.4. So I'm surprised that 13 in 1.3 has this in it. But what we need to do is we actually have a formula for a when you know the vertex and the another point. We're going to take the two y values, so you're going to take 6, and the top one is 12, minus 12, and the two x values, 8 minus 2. And then you're going to say, what is my parent function? Since it's x squared, you're going to square the bottom. This looks complicated, but watch what happens. 6 minus 12 is negative 6. 8 minus 2 is 6. We still got that squared. So this is negative 6. 6 squared is 36. And then this reduces to negative 1 over 6. So our a is negative 1 over 6. Once again, all these formulas, this formula for a, we'll be teaching you that in 1.4. Apparently, I did something wrong. Or did I just... I didn't do the domain. The domain g of x is... So they say that this is the vertex. Do they want just this, or do they want the whole arch? Because if they want the whole arch, then we're moving 6 this way, meaning we'd have to move 6 this way. So that would be negative 4 to 8. I'm going to go with that. Negative 4 is less than or equal to x is less than or equal to 8. Keep in mind that this is set notation that they've asked us to do it in. Okay, no. So they just want the values that they've come from, which is 2 to 8. So in this case, they just wanted what they've drawn here. So we can see here that they've only drawn this part of the arch. So that's the only part of the domain is 2 to 8. So we had a couple of little snafus there, but that's okay, because it's something that you guys will find problem solving within HMW is very important. So let's take a look at 14 here. Red velvet rope hangs between two stanchions, forms a curve, can be modeled by a parabola in the illustration shown. Unit of measurement for both axes is feet. Vertex of the curve is point C, so this is our vertex. Find a quadratic function, so we've got the exact same thing again. So we know that we're going to have a f of x minus h plus k. Okay, so our vertex is at 4, 3.5. So we know that we're going to have a minus 4 plus 3.5. So this much works. Oops, that's the wrong one. So we have a times f of x minus h plus k, and k was 3.5. Okay, I'm going to show you guys the other way to do this, which is now that we've solved this much, let's just stick with the same route. We have, I'm going to use points B and C, keep in mind you do have to use the vertex as one of the points. So you could use A and C or B and C. I'm going to use B and C. So my y value for B is 4. My y value for C is 3.5. My x value for B is 7. My x value for C is 4. Remember, we're going to square that. So 4 minus 3.5 is 0.5. And then 7 minus 4 is 3. Squared is 9. So it's 0.5 over 9, which is 1/2 divided by 9, which would be times 1 over 9, which means it's 1 over 18. So changing out our A for our fraction is 1 over 18. The way I did this is you could either take 0.5 divided by 9 in your calculator, and if I did that, let me just pull up Desmos. Desmos, I've got 0.5 divided by 9. But I need this as a fraction. Right here, convert to fraction. 1 over 18. So if you didn't know how to do what I did here, you could have just typed this into Desmos or your TI-84 and told it to convert the decimal it gave you into a fraction, and you would have gotten the same thing. And our domain is 1 to 7. Farthest left is 1, farthest right is 7. And once again, we're using set notation, so we have 1 is less than or equal to x is less than or equal to 7. Hopefully you guys are remembering how to do these notations. If not, please revisit section 1.1a. That was number 14, so this is our last problem. Looks like this time they actually want us to do a horizontal translation, which is going to be a bit more, or a horizontal compression, which is going to be a bit more obnoxious. The graph of the function g of x equals 1/4 x plus 1 squared is shown. Use the graph to identify the transformations of the graph f of x needed to produce the graph g of x. If the stretch or compression is involved, give it in terms of a horizontal stretch or compression rather than a vertical one. Use your list of transformations to enter g of x in the form g of x equals f of 1 over b x blah 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 blah. Then show why the new form g of x is algebraically equivalent to the given form. So they've given us the formula, which is nice. That is actually going to help us a lot here. However, the unfortunate first thing that we have to do is we can see, we actually don't have to do it algebraically. They helped us out quite a bit. We can actually see how far left or right they moved it. We see that they moved it 4 to the left. So if we want it in this form, then we are going to have f of, I'll go ahead and put this fraction in here, 1 over b. And then we're going to have x minus h plus k. And now we just need to plug in everything that we know. So h is how far left we're moving it. So it's going to be, since we're moving left, it's the opposite of what we think. So it's actually going to be plus 4. So instead of minus h, we'll have plus 4. Now we can see that we're not moving up or down at all. So nice part about this is the k just goes away. We are going to have to close our parentheses here though. Now for b. We had 1/4 here. So our b originally was 4. We know that our fraction at the end should also be 1/4. This equation is equivalent to the given form g of x because x minus I'm not sure what they're saying here. Oh, x minus negative 4 can be rewritten as x plus 4. Then 1/4 can be distributed to the terms of x plus 4, and f of x can be replaced by the action squaring that it performs on its input values. So, guys, that is 1.3. That is the whole homework assignment. And hopefully if you need any more help, you will feel free to give me a holler, and you will feel free to. I never switched back to the other screen. So I am sorry, guys. Let me just go back to this. So we pulled in Desmos at the end of the last problem, which means you guys have not seen anything I've done for problem 15. So what I saw here was they were asking me, they gave me this graph of the function g of x, and they said g of x is 1/4 x plus 1 squared. Let me go ahead and actually, I can't erase it now. So the first thing that I did was I saw that they wanted me to write it in the form that we've been writing everything else. So they wanted me to get h and k. Well, I moved 3 to the left. So I actually put plus 4 here, and then after I put plus 4, they changed it to minus negative 4. And then since it's not moving up or down at all, my vertex is at 0, I could just leave off the k. And then they gave me b already at the beginning, 1/4. So I had f of 1/4 x plus 4 is what I put in. They changed it to this. The equation is equivalent because x minus negative 4 can be rewritten as x plus 4, which is what they have here, except they have x plus 1 because they have distributed the 1/4 to the terms of x plus 4. And f of x can be replaced by the action squaring that it performs on its input values. So that's where that replacement is. So sorry about that, guys. I will make sure in the future that if I switch screens, I will get switched back before I start working on the next problem. Regardless, Wildcats, have a wonderful time. If you need more help on 1.3, please email or talk to me in class.